Example number 6 is our first example with a root in it. But we've done roots before. You had them on your quiz or your test. You had them on practices. You had them on notes. So the idea of having a root with finding a derivative of a root function isn't crazy. First thing we always do is change it to a power, right? All of the rules are the same as last chapter. I'm not teaching you any new rules. The only new thing is if we do find a derivative of a y, give it a little notation, dy over dx. That's the only difference. Okay? So let's do the right side. The left side. I'm going to do the left side of the equal sign first. So, just like we did last chapter, we're going to use the chain rule. So the chain rule says start with the outside. Okay? Then take the derivative of the inside. Chain that on. That's what I'm going to do. Just like I did last chapter. Nothing has changed about that. Okay? So the derivative of the yellow, I'm going to move the 1/2 to the front. I'm going to rewrite the orange, subtract a power, chain. Now I'm going to find the derivative of the orange. Okay? So the derivative of x is just 1. The derivative of 2y is 2, but since it was a y, I have to give it that notation. Okay. And then on the other side, the derivative of 5y is just 5 dy dx. Okay? So that's the derivative part. We're done with the calculus part. The last part is isolating dy over dx, getting it by itself. So I have a dy dx here. I also have one here. I have to isolate it. Okay? So to isolate them, I have to put them on the same side. I have to get them on the same side. Okay, so to do that, we have to kind of take stock of what we have. So I have this times this equals the other part. So if you notice, the stuff on the left, parentheses, that I just created there, doesn't have a dy dx. Right? And then this stuff does. So I want to definitely move this stuff over here. And I want to move this stuff over here. But I have to do it mathematically correct. Like I can't just add or subtract or multiply or divide. I have to do it mathematically correct. So this guy over here, if I want to get this guy over there, I just need to subtract. Okay, so I'm going to do that. Plus, so we want to do this in as least amount of steps as possible. Okay. So now I have all my dy dx's on the same side. I got one there, and I got one there. But I have a bunch of other stuff with it. Okay. So what I'm going to do here is I'm going to multiply. So what I'm going to do is I'm going to distribute this guy here to both of these terms. Okay. That'll get rid of all the parentheses, or most of them, I should say. So negative 5 dy over dx plus when I distribute a property to the 1, it's going to stay the same. Because anything times 1 doesn't change. Plus. And then I'm going to do distributive property to the 2 dy dx. Well, 1/2 times 2 is just 1. Dy dx equals 0. Okay? So now I have 3 terms. I have this guy, and this guy. 2 of them have a dy dx, 1 of them doesn't. So the guy that doesn't have a dy dx, I'll move to this side. Okay, so we get -5 dy dx plus this part, oops, negative root, equals -1/2 Okay, so now on the left, I have just 2 terms. Both of them have dy dx, so I'll factor that out. Okay. Divide by what I don't need. So I get dy over dx equals -1/2 x plus 2y to the -1/2 over -5 plus x plus 2y to the -1/2. Now, could I simplify further? Yeah, you could simplify a lot further. But for right now, I'm not worried about that. I'm just worried about isolating it. Okay. So the hard part about what we're doing today has nothing to do with calculus. We were done with calculus after that step there. Everything under the red line was algebra, was summer assignment quiz stuff, isolating the variable, right? That's something you guys have been doing since 7th grade. Okay? That's going to be the hard part. Finding derivatives is not hard because you guys have been doing that for well over a month. Okay? Almost 2 months now. So that's going to be where the part where the isolating the variable kind of stuff. Distributive property, right? I did distributive property. You guys have done that millions of times. Subtracted something from both sides, divided something by both sides, right? That's stuff you've done before, but it's on a different level. Okay? Okay. So let's look at number 7. Okay, so we have a implicit equation. And then it says, it gives us a little bit different. It says, find the equations of all tangent lines when x equals 0. Okay. So what are the keywords in that? What are the keywords that I should really pay attention to on that one? Equations for sure, because I need equations. So equations of lines, right? Y minus y1 equals x minus m times x minus x1, like you guys have done before. What else is important? Equations of tangent lines. So when we see all tangent lines, what does that mean? What does that mean we have to do? Find slope, right? How do we find slope? Derivative, right? Yep. That means, you write the symbol, dy over dx, right? That's what that means. That's where we're going to start. We're going to start by finding derivative of this guy. That's our first step. We'll go from there. Okay? Okay, so here we go. Let me write this down. Negative x y squared plus 5x equals 1. It's got 3 parts to it. 3 terms. 2 on the left, 1 on the right. How do I find derivative of the orange? Product rule. Okay, product rule. So the first times the derivative of the second. Since I found derivative of a y, I had to give the tag. Now the derivative of the first times the second. That's derivative of the orange. Okay. Now derivative of the yellow. It's just 5. And then derivative of the pink is just derivative of 1, which is 0. Okay, so let me kind of clean it up a little bit. We got negative x. So I'm going to move the 2. Actually, you know what? I'm going to move the negative. I'm going to move negative 2xy dy dx minus y squared plus 5 equals 0. Okay. Isolate dy dx. Get dy dx by itself. Don't wait for me to do it. You do it on your own. Okay? You know how to do it. Try it. If you get it wrong, big deal. Okay? If you're waiting for me to do it, you're never going to try it on your own. And then when you get to the tests, which I'm grading, doesn't help, right? Always try it on your own. If you don't get it right now, it doesn't count. But the more you practice, the better you'll get. Over time, the better you get. Okay, so I added y squared, subtracted 5 to both sides, because those did not have dy dx's. So now the only guy that has a dy dx tag or notation is the negative 2yx, right? Well, I'm going to divide by negative 2xy. And that's the derivative. Okay. Found the derivative. Now here's the question. What do I do with it? What do I do with the derivative now that I found it? Because it wants me to do something, right? It's not just finding the derivative like the last ones have. So what am I going to do with the derivative? Plug in x equals 1. That sounds like an idea, right? That's what we've done in the past when we want to find equations, slopes. We always plug in the value, right? So let's plug in 1. Okay. So when I plug in 1, so dy over dx, I'm plugging in x equals 1. So I get negative 5 plus y squared over negative 2 times 1 times y. I get negative 5 plus y squared over negative 2y when I plug in x's for 1. Is that my slope? No, slope needs a rise over run, right? How many do I go up and how many do I go over? I don't know, right? Because it's got variables. So what I have to do is figure out what y is. How do I figure out what y is? Because if I had a y, I could plug it in. How do I figure out what y is? I have an x. How do I figure out what y is? Plug it into the original. There we go. Plug it into the original. We need to plug it into the original and solve for y. Okay? So we're going to kind of take a little detour here. Going to kind of take a little detour. We'll come back. We'll come back to that guy because we've done it. It's not like we haven't done anything right. Everything we've done so far is correct. We just don't have enough information to go on. So we got to kind of stop. I need a y. So I'm going to go back to the original. Everywhere there's an x, I'm going to plug in a 1. To the original. So I get negative y squared plus 5 equals 1. Solve for y, because that's what we want, right? Subtract 5 from both sides. Divide by negative 1. I get y squared equals 4. So if y squared equals 4, what is y going to be? Is that the only answer? So positive 2 times positive 2 makes 4, right? Doesn't negative 2 times negative 2 also make 4? So it's going to be positive 2 and negative 2 when we take the square root. So that means there's actually 2 points. Remember in the equation in the question at the very beginning it said equations? That's why it said equations, because there's actually 2 that I'm going to create. I'm going to create one for positive 2, and I'm going to create one for negative 2. There's actually 2 spots on this graph that have okay, so there's 2 points that I need to create. So there's going to be 2 equations. So now that I know what y is, let me go plug it in over here. first thing I'm going to do is I'm going to plug in positive 2. So I get negative 5 plus 4 over negative 4, which is negative 1 over negative 4, which is positive 1/4. So let me build that equation. Y minus y1 equals slope x minus x1. So the slope for this guy is 1/4. The x value was 1. The y value was 2. There's one of our answers. Now I'm going to do the same thing, except now I'm going to plug in negative 2 for y, because that was the other y. Oops. So I get negative 5 plus 4 over positive 4. Negative 1 over 4. So the slope for this guy is positive 1/4. It's going to have the same x value, but instead it's going to have a negative 2. So there were 2 spots where x equals 1. It's not a function. This guy is not a function. So you're always taught it's a function if when I plug in x, I only get one answer. For every x, there's one y. It's a function. These guys aren't functions. So for every x, there might be multiple y's. That's the difference between implicit and explicit. All right? If I were to plug in 1 to an explicit equation, I'd get one answer. Plug in x, you get one answer. Because it's a function. These guys aren't functions. So I might get multiple answers when I plug in x. Okay? That's the difference between how they function. Okay? So we've done the equation of a tangent line part. You guys have done that lots of times. Notes, homework, quiz, test. The only thing is we have not done it. So this is just new because it's implicit. These are implicit. Okay? Yes?
How did the negative 1/4 become positive 1/4 from the...
Because negative divided by a negative. This one?
Oh, on the actual equation, you put the negative. It's that one.
Oh, this one here? Oh, okay. Yeah, forgot to dropped it. Yep. There we go. Thank you. Okay. All right. Okay, so now let's do number 8. Number 8 is very similar. They give me a point, but I don't have to come up with an equation. They just want the slope. We did that before, right? Didn't we do that before? We came up with 1/4 and negative 1/4. That's all they want. That's all they want is just that 1/4 and negative 1/4. Okay? So they just want the slope. So I'm going to put that little tag. Since this is our notes, I'm going to put the little tag in here. Slope. Find the slope at that guy right there. Okay. Well, to find the slope, we need derivative. So let's find the derivative. Okay. Draw a line here, separate. Okay, so the first thing we're going to do is find the derivative. So the derivative of y cubed is 3y squared dy over dx. plus the derivative of 2x, 2. The derivative of x squared, 2x. The derivative of negative 2, 0. The derivative of y squared, 2y dy over dx. Here's where these problems are a lot nicer than the other problems we've done, right? What's our next step? After we find this, what's our next step? Normally we'd get dy dx by itself, and then afterwards we'd plug in, right? Here's the nice thing when you're plugging in. You don't have to do isolate right now. Isolating is probably the worst part, the hardest part, right? That's the part where, I don't want to say it's, I hate to use the word the hardest, but it takes the longest, right? Let's do that last. When you're plugging in a point, you can do that before you isolate it. So I'm going to plug in the point now. I'm going to plug in 2 everywhere I see an x, and I'm going to plug in a negative 1 everywhere I see a y. Okay? I'm going to isolate, but I'm going to save that for last. So I get 3y squared dy dx plus 2 equals 2x plus 2y dy dx. Okay, so everywhere there was a y, I'm putting in a negative 1. Everywhere there's an x, I'm putting a positive 2. PEMDAS. Exponents first. So I get 3 dy dx plus 2. Multiplication next. Now you can isolate the dy dx's. Okay? So let's see. 3 has a dy dx. Negative 2 has a dy dx. I want to get those guys on the same side. Positive 2 and positive 4 do not have a dy dx. I want to get those guys on the same side. Okay? Subtract 2 from both sides. Add 2 dy dx to both sides. So over here I get 2 dy dx plus 3 dy dx. 2 equals 2. So everything that did not have a dy dx, I moved it to the right of the equal sign. Everything that had a dy dx, I moved it to the left of the equal sign. Okay, so now what do I do? What can I do now? What do you notice about these two guys here? They're like terms, right? I can combine them. Positive 2, positive 3. So they are 5 dy dx. Since they're like terms, I can combine them. They both are numbers with a dy dx. How do I get dy dx by itself? So the slope of the tangent line at that point, 2, negative 1, is 2/5, up 2 over 5. So when you have a point, after you do derivative, plug it in and then isolate it. I mean, you could do it the other way, but I think this way is a little easier to do. Plug in first and then. Okay. Okay, so now, So that's what an implicit looks like. Does that what all of them look like? No, but that's kind of what an implicit looks like. It's not a function, right? It doesn't pass the vertical line test. If I were to put my pen over, there'd be lots of points where, hey, it's touching the same spot, right? Fails the vertical line test. It's not a function, okay? That's why we don't really talk about it a lot in Math 1, Math 2, and Math 3, because we only deal with functions. But sometimes in this class, there's a few times when we deal with non-functions. Okay, so if I were to graph this guy here, x cubed plus y cubed equals 6xy, you get that guy. That's what you get. Okay, so the first thing I want you to do, find the derivative. Do that right now. Find the derivative, get dy dx by itself. Try it. Try it now. Like I said, if you get it wrong, big deal. This is just notes. But I'd like to see you try it. Okay, so for the left side, if you're still working, keep going, but I'm going to get started. So for the left, be 3x squared plus 3y squared dy dx. For the right side, I have to use the product rule. So the first times the derivative of the second, well, the derivative of y is just 1 dy dx, plus the derivative of 6x is 6y. Okay. Since we don't have any points to plug in, I'm going to solve for dy dx. So there's two things that have a dy dx. There's two things that don't, two terms. These two terms do not have a dy dx, so I'm going to put them on the same side. These two terms have a dy dx, so I need to put them on the same side. Which side? It doesn't matter. It doesn't matter which side. Factor out dy dx. All of those terms, there's two on top and two on bottom, right? I can divide them all by 3, right? So I'm going to do that just to make them a little smaller. So I get 2y minus x squared over negative 2x plus y squared. So here's a question I always get. This is the question I always get. And it's a great question. Which side do you get the dy dx's on? Do you get them on the left or do you get them on the right? Because you will get different answers. My answer is it doesn't matter. Because let's say I got my dy dx's on the left, right? Let's say I said, okay, so dy dx is on the right, this stuff on the left. You would have gotten this answer. And some of you might have. you would have gotten this answer. Negative 2y plus x squared over positive 2x minus y squared. Are those are different, right? They're actually the same. They're actually exactly the same. All of the signs are different, right? In math, if everything is different, it's actually the same in math. Why? Because I could factor out a -1 up here, right? And I could factor out a -1 down here, cancel out the -1s, and don't I get this answer here? So it doesn't matter what side. If you put this answer on a test and you're like, oh, it's not A, B, C, or D, what do I do? Well, factor out a -1. Factor out a -1. Is everything different? Well, the 2y is negative. The x squared is positive. The 2x is positive. The y squared is negative. If everything is different, all of the signs are different, it's actually the same. They're actually the same answer. Okay? So it doesn't matter which side you get the dy dx's on. I usually do the left side, but it doesn't matter. You'll get the same answer. Okay, that's first part. Second part. Here we go. So now find the equation of the tangent line and the normal line. Here's the point. What is the relationship between the slope of the tangent line and slope of the normal line? Flip it, change the sign. So if you find the tangent line slope, to find the normal line slope, you flip it, change the sign. Opposite reciprocal, it's called. All right. So to find equations of tangent lines, we have to plug in values, right? So I'm going to plug in, so I'm going to do the tangent line first. I'm going to plug in my x and y to my derivative to find the slope first, right? So I get 2y minus x squared over negative 2x plus y squared. Everywhere there was an x, I'm going to put in 4/3. Everywhere there was a y, I'm going to put in 8/3. Okay. So 2 times 8/3. 2 times 8/3 is 16/3 minus 4/3 squared. So if I square the top, I get 16. Square the bottom, I get 9. So 16 over 9. Negative 2 times 4/3 is negative 8/3. 8/3 squared is 64/9. Okay. So to subtract the top, what do I have to do to subtract the top? Common denominator, right? So I got to change it to ninths, right? So I'm going to multiply it times 3. So it's 48/9, right? It's the same thing as 48/9. So 48/9 minus 16/9 is 32/9. Same thing on the bottom. Common denominator on the bottom is also going to be 9. So negative 8/9 is the same as negative 24/9. So if I add those together, I'm going to get 40/9. Dividing fractions. Keep, change, flip. 32 over 9 times 9 over 40. (32 over 40), which can reduce to 4/5. Okay. That's the slope of the tangent line. So let's build the equation of the tangent line. Oops. So the slope was 4/5. X was 4/3. Y, 8/3. Done. Now normal line. What's the only difference between the normal line and the tangent line? The slope, right? What's the slope going to be for this guy? -5/4. Everything else is exactly the same. So once you find the tangent line, normal line's easy. It's just opposite reciprocal. Slope is opposite reciprocal. Slope is opposite reciprocal. It means flip, change the sign. Okay. Okay. Couple more things and then we'll be done. There's a couple more ideas that we got to talk about. I want to talk about vertical tangent lines. So if something has a vertical tangent line, what does that mean? It means the slope equals undefined, right? If something has a, kind of jumping around here, horizontal tangent line, what does that mean? Slope equals 0, right? So what we have to do for these two guys is figure out where would the slope be undefined and where would the slope be 0. Where would the slope of the tangent line be undefined and where would the slope of the tangent line be 0? Okay, so what I want you to do first is find the slope, or sorry, find the derivative. Find the derivative for number 11. This one's not too bad. So I got a slope, or sorry, derivative of negative 4x plus 4 over y plus 2. So tell me more about when a slope is undefined. When is a slope undefined? When it's vertical, right? But what makes it undefined? Zero where? Zero on the bottom, right? So this derivative has a top and a bottom. To be undefined, I don't care about the top. The top is meaningless to me because to be undefined, where is zero going to be? On bottom. So what I'm going to do is I'm going to set the bottom equal to 0. Where is that going to be 0? Negative 2. So when y equals negative 2. Did I answer the question? Is y equal negative 2 an appropriate answer? It's actually half the question. What is the other half? Exactly. They want actually, so negative 2 is okay to put in here, but they want a point. They said a point, right? So how do I get the x? Plug it into the original. Plug it back into the original. Plug in negative 2 for y into the original and see what we get. So 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So everywhere there was a y, I'm going to plug in negative 2. And I'm solving for x. Okay. So I have positive 4, negative 8. Those can cancel out because those simplify to be 0. So I have 4x squared minus 8x equals 0. Well, it's a binomial. Does it have a GCF? Yeah. 4x, right? So I'm going to get two answers. 4x equals 0. X minus 2 equals 0. So I get x equals 0 and x equals 2. So there's actually 2 points. 0, negative 2. 2, negative 2. There's actually 2 points that have a vertical tangent line. Because when I factor out a 4x, I just use zero product property to say set them equal to 0, and I got 2 answers. Okay. We'll stop there today, but you guys, so what's the difference with the bottom? When we're trying to find horizontal, we're not going to set the bottom equal to 0. Where are we going to set equal to 0? The top, and do the exact same thing. Okay. So tomorrow we're going to finish the notes.